All right, so this is hopefully after you have the solver, either whether you have a Mac or whether you have a PC. And what we're going to do is we're going to use Excel to solve our linear programming problems. So the first one here, we want to maximize. So this is our objective function. And then we're subject to, we have those constraints. Okay. And so what we need to do is we need to make kind of a table and put all that in it. And then we're going to use the solver function, which is under data, and it's over here, to actually give us the solution to this problem. So the way I've kind of done it is I've got three variables. So I put x1, x2, x3, and below those are yellow. And when I get done, those are going to be my answers. Then I basically write what we have here for our constraints. I'm going to maximize, then I have 27x1, 21x2, 37x3, and then this is going to be what that max is going to be. So whenever I get done, that's going to be my max. So my numbers here I put in red. Again, you can put any colors here. This is just how I did it. I put those in red. This is my objective function answer when I get done. That's the max it's going to be. So it's going to be there the max, or in case of min, if it's a min. And then I have subject to the constraint. So I made the constraints kind of an orangish color. And so that was going to be, again, 3, 1, 1. So 3, 1, 1 based on the x1, x2, x3, and then 1, 1, and then 2. And those are going to also have a thing. So once we kind of analyze it, we're going to get values here. And so those are going to both be less than or equal to, and then it's going to be 5 and 2 because of the 5 and 2 here. Then I also have the x1, x2, x3 greater than or equal to 0. Now, my thing here is this value is going to be what? Well, it's going to be 27 times x1 plus 21 times x2 plus 37 times x3. And that will give me this value. And so that should be what I have to put in here. I'm going to either have to put in a B3 times a B2 plus a C3 times a C2 plus a D3 times a D2 and put that here, or there's something called a sum product. And so I'm basically taking the sum product of the B through D, twos, Ds, and this row here, kind of. So we're taking this row, let's see, better not do that. This row and this row, multiplying them together, and then we're taking the sum product of them. And so that's what that value is. And now this one's going to do the same thing, except this one, we're taking it with the fourth row. We're taking this times that. And what we want that to be is to be less than or equal to 5. And we do the same thing here, and that sum product has to be less than or equal to 2. So that's kind of how I set up this problem. And the key is putting these here right based on your original thing. If you type them in wrong, then when you're doing a solver, you're going to put them in wrong. Okay, so that's the first step, is getting this table down. Now, the only thing left is to do this solver. So you just click it, and now we have the objective. Well, my objective is I want this to be what? I want it to be a max in this case. And I'm changing what variables? Well, I'm changing x1, x2, x3. And what are my constraints? Well, I'm going to add constraints. Since they're all less than or equal to, I can say, well, I'm going to have those two have to be less than or equal to those two. And I can say, okay. Now, make unconstrained variables non-negative. Well, I want those all to be greater than or equal to 0, so I want that clicked yes. And then you can choose one of these things. Since we're doing simplex, we'll leave it as simplex. And now we want to just solve. And if we've typed everything in right, we should get the right answer. Says it found a solution. All constraints are optimally conditions are satisfied. So we say OK. And we see that it's 1.5 times x1 plus 0.5 times x2 plus 0x3. And our max is going to be 51. And I had worked it by hand, and that's the same thing I got down here. So that gives us our solution to this problem. So we get x1 is 1.5, x2 is 0.5, x3 is 0, max is going to be 51. So that's how we do a max. What about a min? Okay. Well, in this case, I'm doing minimize c equals 5x1 plus 2x2 subject to these constraints. And so again, I'm just going to have the constraints put in just like this. So I'm going to have x1 and x2 are the things I'm wanting to change. This is my max objective or min objective function, and it's based on 5x1 and 2x2. And I want all of them to be greater than equal to, and then I just put what they're greater than equal to and put in my numbers here. And then I'm just going to say solve again. Now, in this case, this is my objective, so that goes here. Now I'm minimizing, oops, so we better change that back over here. I'm minimizing this time instead of maximizing. I'm minimizing based on those two variables, and my constraints, I want those all to be greater than or equal to those values. Okay, so that should work. Now, if I've got that, again, I want all of them that's not greater than equal to zero. I'm doing a simplex method again. Sometimes you'll start and it'll be on here. Sometimes it'll be here. It just depends. And then you just hit solve. And it says we found a solution, so we want to keep it. And it says it's 221 and our min is 52. And then it gives me my values, and that's what it is. It's 221, the min is 52. Okay, so that works as far as how the min works. Now let's look at the ones I did in the presentation with the PowerPoint slides. And we had, this is one of them, and we found that max P was 14, X1 is 4, and X2 is 6. So let's see if that happens. Well, again, I'm just going to maximize, and I want the 2, 1 for X1, X2, and I'm doing the sum product as I've been doing. Now notice, this is less than or equal to, this is greater than or equal to. So those are different. So in this case, because it's a computer, we don't have to worry about changing signs or doing any of that stuff. We just plug it in as it is. And once we've got it all plugged in as it is, then all we have to do is hit solver. And so I'm going to say, okay, I'm going to solve. I want the max, and I'm changing the variables, those two, subject to. Now here, I'm going to have to do it two times. I'm going to have to say, well, it's this one is less than or equal to this, and I'm going to add that one. Then I'm going to say this one is greater than or equal to this one. And then I'm going to say okay. And so now I've got the one less than, one greater than. So I've got both of those. I've got the simplex. I've got that. I'm doing max. And so I say, okay, solve. It says it found a solution. So show it to me. 4, 6, 14, which is what we found doing it by hand. Okay, let's do another one. Another max. So this is my set of equations and inequalities here. So it's going to be less than, equals, and greater than. And so again, all that's just typed in already. I just, hand typed it so it doesn't take as long. And then I just have to show you what we do over here, solver. And again, we want to maximize that objective. So we want max. We're changing those three. And we're subject to, now this time we're having this one is less than or equal to that. Add it. This one equals this one, add it, and this one is greater than or equal to this one, and then we say okay. And so now we've got all three of those. Again, it shows me that, so let's solve it. We'll say it says found a solution, 640, 640, and 22. And so that gives me the correct answer. All right, this one we had switched from a maximize to a minimize. And so what we'll do is we'll do a minimization problem. And again, we have to watch what our inequality or equality signs are. And so we go, okay, let's do a solver. And we're going to want to maximize this objective. And we want to minimize now. So I have to remember to hit minimize, otherwise you'll get something funky. And we're changing x1 and x2 subject to. Now we want this one less than or equal to this one. Oops. This one less than or equal to this one. And then we say, okay, add that. And then we want this one equal to this one. We say, okay, now I hit some funky buttons. So let's make sure the D4 less than or equal to 24, which is that 4. And then that one, okay, simplex. And we did the min. So solve. And it says found a solution, 6642. Well, 6642. So that's what we found there too. All right, so our last one we did, we found it was no optimal solution. So what does that look like when we get in here? Well, again, we've typed in everything, so we don't have to worry about all that. So we want to objective maximize. And so we have that, and we're changing what variables, x1 and x2, subject to. Now we want this one less than or equal to this one, add, and then this one greater than or equal to this one, okay. Simplex, those constraints solve. Uh-oh, couldn't find a feasible solution. So Either you've done something wrong or there is no solution. And because we already know there was no solution, that means that would be our thing. There's just no optimal solution to that one. Now, notice it shows a 5, 0, 15, but that's not really the answer. That just gave it the last one before it failed and was not a feasible solution. And so you can't just go by what you saw here. You have to actually remember, okay, what did I see over here? It couldn't find a feasible solution. And so that's what you have to remember. And so it basically couldn't find a point for all constraints being satisfied. So that's a kind of a key. You really have to pay attention to when it beeps, what does it tell you is the solution? Okay. All right. Well, okay. So, and you can see here, if 10 is not greater than or equal to 12. So that's kind of the key piece. It's that one doesn't work. So that's where it fails. All right. So hopefully that will help you. Again, the key point is setting up your tables here, plugging in the right things into solver and then solving it and then pulling out what you need there. So hopefully that will help you with this assignment.